Hey there, everybody. My name's Jesse. I'm one of the TAs here at U of H, Chemistry Department. This is going to be the video for your density lab, the Excel portion. If you go to your lab manual, you'll notice we go through in great detail how you're going to use Excel or some similar software to process and analyze your data from your density lab. Excel is kind of a fancy calculator, but it's so much more than that. It's a very powerful tool, and it's probably one of the most important things you're going to learn in your science education here during your time at UHM. When I was about where you're at, freshman, sophomore level, I didn't know how to use Excel. I was terrible with it. After maybe a few classes, I could do an XY scatter plot and get a trend line, but beyond that, I was confused and scared, and I would, be in a physics course where the computer science majors, they just knew how to groove on this. And, what I'm going to do here is try to break down that barrier, because if you're in my shoes, where I was when I was your year in college, I just don't want you to be scared of it. It's really easy once you learn how to use it, and so hopefully we can get you started on this. Some of you are probably already really great with this, but there might be something you can learn from this video as well, and if anything, it's just going to help you with your density lab. Starting off, start with a joke. Why do we say chemists love density? Well, my friends, it's because it is mass over volume, and it makes it hard. It's a nice little memorization tool. You're getting a lot of equations spit at you in chemistry, and you might get a question on a test asking you, what's the density of this? And you're like, oh shoot, what's the formula for that again? And that's okay. It's a simple formula, but maybe you haven't used it, and so this might help you memorize it and keep that logged away. This right here, this is Greek rho. What we use for density. You'll see that in physical chemistry quite often, and you're going to have different types of units. It can be mass in grams, volumes in centimeters cube. Well, a centimeter cube is also a milliliter. It can be kilograms per liter. However it is, it's going to be some unit of mass over some unit of volume. And the important thing is that your units agree when you're doing your calculation. Always write your units. Okay, so I really want to just get into this. Oh, shoot, you guys see how nerdy I am. All right, there we go. So, we don't want to see that. That's the filled out version. I got a nice blank one for us, and we're going to fill it out together. This is going to follow along with the grid of the one in your lab manual. Let me go and pull up this PDF. They give you some instructions here, and so if you like, you can follow them to the T if you're very scared of Excel and you just want to kind of follow a recipe. I made this Excel in the video fashioned after this one. However, you don't have to use Excel. There's free software out there such as OpenOffice, other programs. However, at U of H, you pay student fees. Those student fees go toward software packages. So you have a free version of Excel waiting for you to download. Maybe I'll see if I can get you that information through Professor Fuller. But when all fails, what I've always done is I just talk to the IT people. I would normally go to the library, obviously, because of the age of COVID, we can't exactly do that. You can always shoot them an email. If you have a friend that did so, you can ask them, hey, how'd you get this? There's an online version, which means you always have to log in to use it. You have a downloadable version that you can get access to, that you keep on your own computer. I highly recommend that. And as I said, you can use OpenOffice or something else. However, you're going to eventually have to learn Excel anyways, in your professional career. It is the spreadsheet software. Might as well bite the bullet and get into it now and give yourself an easy time later. Now, there is some other nuance here. There's PC users and there's Mac users. I'm going to be doing this obviously on PC. The biggest difference is, yeah, they're going to do the same thing, but the buttons are going to be different where things are located on PC compared to Mac. I help students when I'm tutoring on their Macintoshes with Excel, and I get so confused. I'm like, oh, how do I do this simple thing? And so I'm sorry if you're a Mac user. No judgment, but you might have to play around a bit. It's going to be different from what you see in my video, but the functions and instructions are all the same. And again, any little thing you need to do that I don't show you, you can Google it. You can go on YouTube, and so many people have put out thousands of videos of how to do some simple thing. In fact, when I was setting up this video, I learned how to do something Excel I didn't know how to do before, and I've been using it for almost 7 years. And again, you can do very simple things on Excel, like make an XY scatter plot. And I've done labs in advanced physical chemistry senior level labs where we obtained quantum mechanical parameters from polarization experiments with HCl and DCl and HBr and DBr. And you don't need to know that, but no, it's if you're doing some big experiment for NASA, you might be doing it on little old simple Excel. So here we go. I'm going to give you a little bit of a rundown here, but I'm going to go through this brief, and I might make another video to show you some finer points of Excel that really show you the full power of it. But so essentially, here's what's going on. These are just little blank blocks and grids. You have A through, Z. You can actually go beyond that and go double A, double B, however. And then the rows are going to be numbered. And so it's just like Battleship. Let's say I said I need to go to K13. Well, here's K, and there's 13. See how it highlighted over here in green when I clicked on that? It's just some sort of coordinate. So each of these, you can scroll through, see in the upper left-hand corner how that coordinate changes. It has its own thing going on. And see how if I go to A1, well, what's typed in A1 is up here. This is like a little argument bar. Like, hey, not people arguing in a bar, but just like an equation or, something has an argument, well, whatever's inside of it will appear here too. You can type into both of them. I like to select the box and then do my typing up here. You might notice, well, why does the rest of these words appear in these other cells? Well, that's just because, see, I made that column that big. It ran out of room, but it's still going to show me what's in there. So B1 doesn't have anything in there. It's just A1 is displaying through it. And I could fix it by doing this, right? So, okay, there we go. But you don't have to. Well, actually, here's a good thing. Say I wanted to revert that change. Control Z. Boom. Awesome. Okay. So I went through and I just labeled these, just as they are in your book. You can do the same, or you don't have to. You can do it any way you want. And going through these, anything I've typed in there, it's up in the little argument bar. You can put words, numbers, you name it. It's in there. You might have noticed if you were to go right-click, I don't know what it is on Mac, but on PC it's right-click. I can change the color. It's not important, but it makes it easier on my eyes. I made every other one gray, Okay, let's get into it. So for this, hey, we have mass. It's good to preface. In this lab, you will have some other video, going through the lab itself. We're going to be taking Teflon balls. Teflon is a fluorocarbon, so it's like a hydrocarbon, but fluorine's where the hydrogens normally are. And so your frying pan has Teflon on it. That's why things don't stick to it. It's a very inert thing that doesn't want things to interact. It's kind of doing its own thing. And so we know we could put Teflon in water, and water's not going to stick to it and affect our measurement. And so that Teflon ball is going to have some mass that you would normally go to the scale in the lab and find a mass. Remember, in chemistry, we don't weigh things, we mass them. And in SI units, which in this case is grams, then you would be putting it into some sort of water, and you would see, just like Archimedes learned, in his famous experiment when he was taking a bath, he noticed when he got in the water level rised, and he realized he's the guy who says Eureka. He said that because he realized, oh, the water is showing my body's volume, and he went running through the streets naked, and the rest is history. So it's going to displace a certain amount of water. The water will rise in the test tube, and you could measure how many milliliters it rises by. Well, dimensional analysis tells us 1 milliliter is equal to 1 cubic centimeter. And so through that, we know how much it weighed, divide that by how much it displaces, boom, you got a density. So the thing we need to do is to tell Excel to make these calculations. It's a little bit like coding in that sense. So let's see here. First things first, we got density, right? Well, we wanted to take some mass and divide it by some volume. And we want to do that for sample 1 and only sample 1, right? So check this out. I've clicked on D5, and I'm going to say, well, I got mass, which is B5. I've got volume, which is C5. So I should probably go B5 divided by, now computers have their own language of math. It's really good to learn it. Learn it now. You're not expected to just know it, but over time, throughout your undergrad education, you'll obtain this information. Well, it's that. It's /. That's divide, So B5 divided by C5. Sorry, I know, just yelling out numbers and letters, it can be boring. Bear with me. Let's say you know when you type in a calculator, you're not sure if this would be B5 divided by C5 times, D5. You don't know if, is this B5 divided by C5 and then times D5? Well, you can uncomplicate this by using parentheses. I overuse parentheses in Excel and certain calculators just so I'm sure my values are going straight. So you could understand how this puts D5 in the numerator, but if I group it with C5, it keeps it in the denominator. And it's subtle, but it's like grammar. Every little bit of difference of computer math language determines everything. So anyway, I'll try not to go off on too many tangents. Let's just get her done, I suppose. Okay, so you'll notice I've done that. Okay, it just says B5 divided by C5. Well, it doesn't become a function until I add an equal sign. And I always like to do this last, because if you make a mistake or something and you have the equal sign first, sometimes Excel freaks out and doesn't do what you want it to do, and you have to backwards navigate, and it's a hassle. Look at this. The B5 got highlighted in blue. The C5 got highlighted in red. Well, look, my mass is in blue. My volume's in red. I just realized, let's zoom in a bit. You guys might be on your laptops, and this might be hard to see. There we go. Okay, sorry about that. That's better. Okay. So you might notice once I press enter, Excel does not compute. Well, I don't have any values in there. I could go, okay, hey, what if I have 1 gram and it displaces 1 milliliter of water? That's actually the density of water about. Hey, I have a density of 1, So it won't do anything until you put values in there. I'm going to hold off on that till a little bit later. So here's the magical part of Excel. You know that equation we made, and it did it just for sample 1? Well, what if I wanted Excel to then automatically do the same thing over for just sample 2, and then just sample 3, and yada yada? Well, here we go. Click on your equation cell. In PC, it's right click, and we're going to go copy. Should be the same on Mac. Then I'm going to click the cell below it. See, I've copied a mathematical function. Click and hold the cell below it and drag to every cell you want it to do that to. To the very end. I have 12 samples. Then I let go of that hold on my left click, and then I'm going to go right click. Again, it might be different on Macintosh. And you could paste. You could paste just the numbers, yada yada. Look at this, f of x. That's a function. Paste that. Now look at this. Right there. It propagated the same type of mathematical function, but for this set. It didn't grab a value from sample 1's mass and divide it by sample 4's volume. No, it kept you can see up here in the argument bar, kept the ducks in line for us. That's awesome. That's the power of Excel. Okay, now that we have that, X. In statistics, X means your sample value. We're going to be throwing some statistics at you here too. A lot of people find general chemistry hard because they think chemistry is hard. Well, really, it's probably one of your first physical science courses that's very quantitative. And so we're teaching you how to science in chemistry that's going to help you in biology and physics and other stuff. So even if you don't continue in chemistry, you're getting tools that are pretty universal here, and that's why it can seem jarring. Chemistry itself is a very elegant field, and it's not that hard. It's really intuitive, So anyways, I'm going to click on that cell. This is just a label. This doesn't do anything. I'm going to click on the cell that the label is indicating for, and I could go X average. You could type out a formula, and put the values in there, and then, divide it by how many you have, or up here, we go to insert. Okay. Formulas. See, I've been using this for years and I still forgot where something was. See this thing? We have some functions we can choose from, some very common ones. Well, let's use average. And then I need to highlight what I'm trying to average. Click and hold. Okay, I want all those. Oh shoot, see? This is a perfect learning moment. I thought I told Excel to do something and it didn't. Let's see what happened. Well, it didn't ruin any of my equations. Those are all the same. Let me go back to the cell. See what I did. Average, okay, there we go. Maybe I didn't have it highlighted. Teachable moment. So it's asking you, well, what do you want to average, dude? Well, I want to click and hold. I want to average all these values. I want the average. See that? How it said D5 colon D16? It's going to take the average of all the values from D5 through D16. Press enter. You notice this grams per centimeter cubed. That's just a label I added. It's nothing. Okay, this one. This is the sum of, what is it? The sum of difference of squares, I think the terminology is in statistics. You might say, oh, you have a math equation in there. Can't I just use that? Well, I use some fancy Greek inserts just to have a nice label. We actually don't need this. So what this is saying is xi, well, x is your sample. I is just numbered sample. So we always start with, like, let's say 1. Oh, sample 1. Okay, this guy or gal. Sample 2, sample 3, and so on. And it takes each sample value subtracts it from the average, and squares it. Then it takes sample two's value, subtracts it from the average, then squares it, and adds it to the last one, and then does, so on and so forth till we have all of our samples accounted for. So let's see here. What do we want to do? Oh, we're actually not ready for this one yet. See this term inside our parentheses? That's this up here. So here's where it gets fun. Well, xi is sample one's density. So we know we need this value, D5. Okay. Then I have to subtract it from the average. Here is something I learned while making this, that I always wondered, I knew how to propagate this function, but I was like, well, what if I want to hold on to one value, some constant, and then propagate in the thing? And so I would always have to take a column, let's say the acceleration, the acceleration due to gravity, what is that, in meters per second, right? And what it was, like 9.81 meters per second. If I had some function going off in here, and I wanted to just grab that one value and it's being recycled, because it's a constant, with the other variables that are actually changing, I would copy and paste this as a value. Yeah, this is really stupid, isn't it? And then I would have my my x variable here, my y variable here, and then I would have my function, and then so it would propagate the function based on the changing x and y variables, and then it would just grab the same constant. Well, here's where we can fix that. It turns out, let me go to my template, make sure I have the equation right. Okay, perfect. Turns out, by wrapping, I want to grab the average, this value here, D17. Bingo. Turns out if you take a money sign and wrap it in the letter, 2 money signs, then 17. Okay, let's check this out. I'll give it the equal sign. And again, you can type in the box or you can type up here. I typically like to type up here. Give it the equal sign. Look at that. Highlighted in blue. That value, the sample one value of density, minus the average down here. That might not seem so miraculous, but watch this. Watch this. Okay. Again, don't be bothered that there's not numbers in there yet, because we don't have any values. Copy that function, doing the same thing we did with the density. I'm going to paste the function. Watch this. Look at that. It grabbed sample 2's value, but subtracted it from the same average. Sample 3 value, same average. Excel magic. I mean, I'm this old, been using it this long, I finally learned how to do that. Yeah, embarrassing. Okay, so then this sum, it's gonna take this value and square it, and then add it to this value that's squared and this value that's squared. So let's square them now. Okay, so we see how we have this term, the next row over or column over. We're taking that value and we're just squaring it. See, I think I messed up with my superscript and subscript. That's fine, don't worry. So all we do is then take, well, value E5. Yeah. Okay, here's where, again, math language. Computers can do math, but they have their own language. So for a power, you use caret. It should be, shift number 6 on your keyboard. And square is 2, so caret 2. Then equal sign. Boom. See that? It grabbed that value, and I know I'm squaring it. Another thing, when you see a square root means whatever's under that square root to the 1/2 power. You could do square roots like this. 1/2. Oh, I square rooted it. Okay. Well, in this case, we want to square it. All right, parfait. So, just as before, what do we do? If Excel's like, you're like, no, I don't want to be on that, just click some random cell, you know, just to reset yourself. A random empty cell. Okay, clicking back on that cell, I'm going to right click, copy. I'm going to propagate. It's going to do the same thing to all these sets of values. Paste the function. Now, okay, I have this term, xi subtracted by x average squared. Well, here we have it here. I want to take the sum of these. Well, the sum just means you're adding them up. Okay, so I'm going to click there. I'm going to make a function that's going to add all these values. So we're going to go to auto sum. Hey, it's the first one. Boom. What do we want to sum? Well, I'm going to click and hold. I'm going to add these up. In fact, just so you know, when you are using pi or exponential in your calculator, well, a calculator can't sit there and draw a unit circle and do cosines and tangents like you, the smart human being, can, but it can take an infinite series and sequence and add a bunch of numbers together and converge on some value. That's how calculators calculate pi. So they're good at this. Okay. Again, F5 to F16. Oh, F5, F16. We're summing all those. Enter. Okay. Now we have the standard deviation. I wrote 2 here. Excel has a function, but there's also an equation. If we go to our lab manual, right here, when I took statistics for scientists and engineers when I was, I think, a junior in college, maybe sophomore, I would get confused whenever they would have a sum function. That's all this is. It's a summation function. You'll learn about them past algebra. And next to a square root. This should actually be, see how square root's like a check mark? Remember, square root just takes everything under it to that 1/2 power. Well, this function for standard deviation, when I made this, I went through like just a dry run, and I'm like, why is it not calculating it right? It didn't agree with what Excel had from its standard deviation function. Well, you know, I had to pull out my statistics book and find the function. You know, I keep all my textbooks from my undergrad. Should too. This check mark, this line, it should actually go over all of this. And you might see at the end of a square root, sometimes they have a little down tag that indicates the termination of the square root. So I don't know if this is correct or a typo. It's been a while. I forget if you're allowed to do this, and it's saying no, the summation is included because you're multiplying it by this. If I was drawing this by hand, I would terminate it. So this is the function we're going to enter in. So n is the number of samples you have. It's a common theme in statistics where you're going to do some sort of test and you don't want to double count. There's a lot more that goes into it. I won't bore you with, but it's a common thing. Number of samples minus 1. Well, in this we had 12 samples. So let's write out this function. Let me go dual screen here so I can do. Okay. All right. So let's take this math and put it into this bar. Alrighty. So let's start with the parenthesis. That's always a good idea. That just means, hey, we're going to start some function. All right. Let's focus on this term right here. So each term, let's give it its own parenthesis. Well, that's going to be 1 divided by, well, let's say I want to keep the denominator all by itself. Another parenthesis. I go overboard with these. In this case, it's 12 minus 1. You know, it's number of samples. Well, I have 12. You could just put 11, but for our sake, I'm going to put it as it's written. Whenever I enter something into a calculator or something, I like to write what I see written on the page, just for my own sanity or insanity. Okay, Parenthesis again. See, I terminated. Well, watch this. There's a reason I do that. Let me put the equal sign. Okay, look at this. See how, oh, this might be hard to see on your screen. See how, watch this. Let me do another one. Okay, see how the first set of parentheses, when I go on it, the other one it complements on the other side is in black and it reacts and it kind of highlights. Then the next set, the red one, well, it's showing you, look at what you're bubbling and grouping. So I have that whole term in the red parentheses. That's good. I have the whole denominator in the purple parentheses. I just wanted to show you that real quick. Okay, this is where you would likely make mistakes in Excel. You know, even if you know what you're doing. Nobody's perfect. Okay, we're ready for our next term. Well, it's all of this. It's saying you have some number of things, in this case samples, and we're going to count the things starting at the first one. And in this case, it's saying, well, the first one's going to be number 1. And I know you're thinking, like, that's stupid. Of course it's the first one. Sometimes you have series that start at 0, you know, or start at 5. This is math language with its own particular grammar indicating some specific thing. Okay, well, you know, we don't have to enter this equation in Excel because guess what? We already calculated it. You see that? All right. So all we have to do is then take this value. So that value is contained in D18. Yeah. Okay. So we're going to multiply. Multiply is, you could either parenthesis, star means multiply also. And that's one term, so I'm going to give it its own sets of parentheses. D18. All right. Close parenthesis. Terminate. Okay. And then, remember I said this is all square rooted? Well, it's all to some power. Well, it's all to the 1/2 power. You know, another thing with math, since I got you here, you might see, I don't know if you can see my cursor, but see this square root check mark. Sometimes there might be a 3 there, or a 4 there, or any number. So, you know, the cubed root with 3, guess what that means? To the 1/3 power. Fourth root, the 1/4 power. Isn't that easy? Somebody had to make up all this math language to make us think we're not smart enough to do math, when really you are. We just say these are gatekeeper words. Well, guess what? You're in college, you're going to learn the jargon, and you're going to be better for it. Okay. So, we got that, but it's not going to calculate anything until I give it an equal sign. Look at that. D18, it grabbed that function value I wanted it to. And I can press enter. Now, here's where Excel has its own function. Let's say I want to insert, no, formulas. There we go. Where is it? There we go. Okay, see how I clicked on insert function? First thing to come up, STDEV, standard dev. All right, we're going to use that. Now let's see, what are we standard deviating? I think in this case, let me double check. I have a cheater here. Don't look. Okay, perfect. When we're doing the standard deviation, we didn't need all this. Now, you should do this for your lab, because you're going to learn how to use Excel and do statistics. But the point of this is to show you how it works, so you know the working parts of, this is a machine. You're going to know how the engine runs. So later on, you can use the shortcuts, and if something goes wrong, you know like what's going on inside and you can fix it. So we're going to standard deviation. Well, what values? Well, our sample density values. Bing, bang, boom. Okay. This delta, this is going to be the error. Let's see, how did I do that? Okay. The uncertainty. If we go to our lab book, boop, 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 we had an uncertainty. Sorry if my scrolling is giving you motion sickness. Let's see. I made all this a while back ago, so I'm a little rusty with this lesson plan. I had it a second ago. It's up higher. Yeah, here we go. Okay. This was gonna be, I think, a confidence interval thing. Come on, Jesse, get your act together. Yeah, okay, perfect. Make sure you're reading the manual because you're not going to get the whole lesson from me talking. This is just to show you how to use Excel. There's my cop-out. Okay, confidence interval. If you're really curious about them beyond this, you can pick up a statistics book, maybe I would highly advise taking statistics of some sort at some point. It's fun, and it's not math. It's its own science, so it's cool. You can major in statistics. Statisticians make a lot of money. Anyways, so read this, you'll understand what's going on here better. We're essentially taking some confidence interval, plus or minus some value, with the standard deviation over the square root of number of samples. So, I did this before already. I did the math language right here. And so, yeah, that's how we're going to do it in the other spreadsheet. In fact, I might even be able to copy. Excel does copying and pasting too. It makes things a lot easier. Okay. Alrighty, cool. And even though I got the script from a different sheet, it's using the same language. I have the things in the same place, and so should do what I tell it to. Okay, what did it do? No, it did not do what I wanted it to do. Oh. Okay, there it goes. Again, sometimes Excel, it's haunted. It doesn't exactly do what you want it to do. Okay. So it took the 1.96, it multiplied it by this whole term, which was standard deviation over the square root of number of samples. I have all that information in there. Okay. We're about ready to rock and roll here. Delete that nonsense. Why won't that delete? Oh, come on. See again, Excel. It's haunted. There we go. See, isn't that weird? I just did that and it wouldn't take the command. Thanks, Bill Gates. So, now here's what's really cool. You might be like, well, this is bullcrap. I can't do anything with that. Well, we got our functions in there. Let's throw some data in there. This is not gonna resemble the data in your actual lab. I just kind of made some random, this seems reasonable. So like, what was it? Okay. See, we had something that weighed 1 gram and displaced 1 milliliter of water. Oh, cool. We have some density. I'm going to make this quick since I've talked so long already. I've prepared some values. These have nothing to do with Teflon. I didn't even Google anything. I've taught this lab, but I don't have a sample data on me. I think it's back at the office. Okay, I'm going to just put some values in there. Wowie zowie, look at that. Okay, these functions were already ready to go. It said, hey, you give me a density, you give me a mass and displacement for sample 1, I'll give you a density. Do the same for sample 2, I'll keep doing it. Whatever you want, guy or gal. And so I have those values in there, and it's giving me density. Yay, for each individual one. Then I have an average density. Then I have a sum of the, the sum of difference of squares. I have a value for that. Therefore, I have a standard deviation. Therefore, I have an uncertainty. It did all that for us. When I first took statistics, we were using a program called R that does this. I didn't know how to use R, so I did all this crap by hand, but much more data, and it was painstaking. Don't do that. Use Excel. It's your friend. So one thing you notice, I have these negative values. I think the real equation would have an absolute in there, but when you square a negative, you lose that. It's always going to be positive, so we didn't have to worry about that there. Let's see here. One other piece of information that I think is important for this. Again, I'll probably make another video just to go over some individual aspect, but while I have you, okay, let's see here. Rise over run. So let me take my mass and displacement data. Let's do a quick little exercise. So Excel likes to, actually, let's keep the format of that. I like my coloring. Just paste. You did paste. Okay, Excel will always make whatever's in the left column X and what's in the right column Y by default. If you forget, you can always Google that. Oh, here's one. I just highlighted all that. Control C, copy. I highlight where I want it to go. Control V, paste. You're already way ahead of me than when I was in Gen Chem. Okay. So the reason I'm doing this is I have some X and Y data. Let me think about this again. Rise over run. Yes, perfect. Okay. So I'm going to highlight this. I'm going to go up to Insert. And again, it's going to be different on Mac. I'm so sorry, guys. You should have started off with PC. A lot of science is done on PC. I know some biochemists. Astronomers use Macintosh. I know some biochemists that use Macintosh, but I'm sorry to say, everything else is done on PC, and it's cheaper. Why would you want to spend more money? Okay. So here's my scatter plot. Yeah. Okay. A lot of undergrads like to use ones with lines. No, just scatter. Just a scatter plot. I'm not even going to make this look pretty. Maybe I'll save that for another video. It took my data. This is my X column. This is my Y. And I don't have any labels. I'll make a video for that. But just to show you really quick. Milliliters displaced, grams. What do we know about slopes? Rise over run. Grams over milliliters. Oh, that's density. Okay, we'll go to chart elements. Trend line. Again, I'm going to make a video to show you all this fancy stuff I'm doing right now, and even better. Okay. All I did was, there's a little thing here. I said I want a trend line. I clicked it, and then I went onto this. I said I wanted it to be linear. And then it allows me to format even further. Okay. And that's when I selected display equation. So this is the equation it gets. This is just simple linear regression. This is what we use Excel for most of the time. Y equals mx plus b. B is the y-intercept. Well, if it crosses the y-axis when that value is negative that value. What we care about is the slope. So if this was our data on some one material, no matter how small we had, yeah, smaller size can have a smaller mass, bigger size, bigger mass. Well, take all the data for the varying volumes and masses, and the slope is the density of that material. It's telling us this material is about 1.1684 grams per cubic centimeters. There it is. okay, I've gone on long enough. Hopefully this was helpful for you. This was a lot of fun for me. When I'm teaching this lab in person, I have no way to just show all the students this at once, and so I'm doing it individually in tutor time. It's a long time coming that I just make this darn video. I hope you enjoyed it. I hope it was helpful. You know, I know we would love to be doing these labs in person. As far as I know, these will be kind of a hybrid online course because of COVID-19. But we're going to do whatever we can to make this as great for you guys as possible. And, you know, hopefully maybe we can even make this better through this online learning thing, and you guys can actually learn more. This is already way better than me teaching Gen Chem and Lat in person, because I can show you all this. So, okay, that's the video. Thanks, everybody.